Hi guys, hope you all doing well. So here we are going to analyze each and every question of csir net November 2020 Chemical Sciences with a best conceptual analysis along with extra information which may be useful for your further preparation. So watch the video completely and click on like and do subscribe our channel for further updates. And if you are interested, you can visit and join on our chemmasters.online website for the best concept oriented online courses. Okay, now just look at the given question. Choose the correct statements for the group 15 halides. So just look at the first statement. Arsenic trichloride can form complexes of type arsenic tetrachloride anionic complexes in the presence of a chloride source. The second statement is trifluorophosphine acts as a strong sigma donor ligand towards D metals. Third statement, in the solid state, stibinum pentafluoride has a trigonal bipyramidal structure. Fourth statement, the reaction of stibinum pentafluoride with anhydrous HF, hydrofluoric acid, generates H2F+. Okay, so we need to pick the correct statements. Okay, now just check the reaction, that is the first statement. Arsenic trichloride, whenever reacts with Cl minus, it produces the anionic complexes as arsenic tetrachloride. Okay, you can see here. This is the correct statement, and here we need to apply the basic concepts to find is it going to give the correct complex or not. To do that, so just check arsenic here. We know that arsenic belongs to nitrogen family, which have the valency electronic configuration as ns2 and np3. So just try to take the orbitals here. So one is paired in that ns2 and here np3, so single electrons in each of the orbital. Now each chlorine just that means simply gives the other electron and make a bond, and here the electrons are dragged onto the chlorine. That's because the more electronegativity of chlorine when we compare with the arsenic in that case. So we can show RS like this, and chlorines with the here what we say, the ionic nature, and chlorines with negative charge. That means the negative charge is attained onto the chlorine. Okay, in this case arsenum is in +3 oxidation state and each chlorine with -1 oxidation state. Okay, so this is the case we can see, right? And in the next step, what is happening? Chloride ion is going to add into this arsenic trichloride. So where is the possibility? Because here the arsenic has the d orbital, the empty d orbital. Okay, so here then the chlorine with the negative charge can make a coordinate bond. Okay, so simply in Cl minus act as a ligand, right? And it enters into the empty, that means it gives its electrons into the empty d orbital of that arsenic. So in this case you can see 3 chlorines are here. Just write down 3 chlorines are ionic in nature. That means we can see ionic bonds here. And the next case where the other chlorine is a simply ligand, that means it is forming coordinate covalent bond, right? Coordinate covalent bond. That's why we can see in that anionic arsenic chloride complex, tetrachloro complex, we can see ionic nature and coordinate covalent nature, right? Just observe it. So that's why here there is a possibility to make that AsCl4 minus. Okay, right. Now based on that we can say that the first statement is the correct one. Now just look at the second statement where we have given with trifluorophosphine. We know that so fluorines are more electronegative, that's why always they drag electrons towards them from that phosphorus. So whenever it is coordinated with the metal, so the electrons from the metal drags into the empty d orbital of that phosphorus because of more electronegative fluorines are there on the phosphorus. Okay, that means electrons are dragged towards the phosphorus, that means into its empty d orbital. That's why here trifluorophosphine act as a strong pi acceptor instead of sigma donor. Okay, that's why we can simply eliminate this second statement, that is the incorrect statement. Now just check the third one. In the solid state, stibinum pentafluoride has a trigonal bipyramidal structure. Now in its gaseous state, stibinum pentachloride almost exists in a trigonal bipyramidal structure. But whenever we see the stibinum pentafluoride in its liquid and solid state, it is going to exist in the form of octahedral geometry. That means polymeric stibinum pentafluorides are there, and which makes octahedral geometry. So you can observe it by just taking the structure here. Okay, just wait. So stibinum, and just draw all of them. That means all the fluorines here. Okay, now in the next case, what happens? So the fluorine of another stibinum you can draw like this. So which makes a bond like here. Then fluorine here. So in the next case, here we have the 4, right? Then so this will be the another one. That means we need to give for it. So just to wait here. So like this, they are going to make octahedral geometry around stibinum by just sharing the fluorines of one of the two or more polymeric stibinum pentafluorides. That's why here in the solid state, stibinum pentafluoride has octahedral geometry instead of trigonal bipyramidal structure. That's why third statement is also wrong. Now just look at the fourth statement here. The reaction of stibinum pentafluoride with anhydrous HF generates. So we know that stibinum, and it is the popular reaction, and we may come across on this reaction many times in CSIR examination. If you see previous year papers, you will get most of the cases on stibinum pentafluoride as their superacids, and how they give the complexes and etc. Okay, different questions are there. Yeah, stibinum pentafluoride whenever react with HF, then it produces SbF6 minus and H2F plus. So that's why the fourth statement is the correct one. So from this, 1 and 4 are the correct statements, and option 1 is the correct answer. Okay, right. Thank you very much.